Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to the channel Baloch Scholars. So today I am going to complete the remaining portion of the introduction of first chapter, that is real numbers. So let's start. In the previous video I defined what real numbers are. Okay. Furthermore, I discussed about the natural numbers, all numbers, integers, positive integers and negative integers. Okay, now I will be discussing about the rational and irrational numbers. Okay, what are rational numbers? The word rational is derived from ratio. Rational is derived from ratio. This means it is the ratio of two integers. It is the ratio of two integers. Rational number is derived from the word ratio. Okay, also it can be called fraction. It is denoted by P over Q. Okay, it is expressed as P over Q. Rational number is expressed in form of fraction, mean P over Q. So the denominator Q is not equal to 0, means the denominator cannot be 0. Or for example, the 1 cannot be divided by 0. 2 cannot be divided by 0. So you cannot call these rational numbers. Okay, rational numbers are expressed as P over Q, such as 3 over 1, 5 over 2, okay. Rational number is denoted by capital Q. Rational number is denoted by capital Q. Okay, it is expressed or written in form of P over Q, means it is written in the form of fraction. For example, 3 over 8, 7 over 2, minus 4 over 5, 0 over 1. So as I told you, you cannot make the denominator 0. Okay, so furthermore, another type of number is irrational number. It is the opposite of rational number. It is the opposite of rational number. It is a type of real number. A real number that cannot be expressed in the form of P over Q, means it cannot be expressed in fraction form. It cannot be expressed in fraction form. Rational numbers can be expressed in fraction form, means P over Q. So these irrational numbers cannot be expressed in P over Q form. And this also Q is not equal to 0, means the denominator is not equal to 0. Okay, it is denoted by Q over dash. It is denoted by Q dash. If Q is the set of all rational number and R is the set of real numbers, then the set of irrational number is, means if we donate the set of rational numbers from Q and we donate the set of real numbers from R, then what will be the set of irrational be donated? It will be donated by Q dash. Okay, this is the set of irrational numbers. Irrational numbers cannot be written as fraction of two integers. I told you that irrational number cannot be written in fraction forms because they are irrational. Their decimal expansion continues forever and does not repeat any pattern. Means they are non-terminating. Irrationals are non-terminating and do not repeat any pattern. Irrational numbers do not have any pattern. Irrational numbers are non-terminating and non-repeating numbers. Okay. For example, if I give you the example of pi, this is the pi. So the value of pi is 3.14159 and it is continued. It is non-repeating and non-terminating. It is continued. So it is irrational. Further, 2 square, okay, it is in the square form, so it is non-terminating and non-repeating. Such numbers also phi and such numbers which are in square form. Further, there are some decimal fractions. We can say terminating decimal fraction, recurring decimal fraction, non-recurring decimal fraction, non-terminating or non-recurring decimal fraction. So we are supposed to find out which of the following is a rational number and irrational number. Okay, the first one is terminating decimal fraction. So terminating means ending decimal fraction. The decimal fraction in which there are finite number of digits in its decimal part is called terminating decimal fraction. Means there are finite number of digits in its decimal parts is called terminating decimal fraction. So this is the example 0.50. Okay, after the decimal there are two numbers, so I will be putting 2 extra 0, means 50 over 100. So it is written in the form of P over Q. So another example 2.25, 225. So after the point decimal point, two numbers are there, so I will be putting 100, 225 over 100. So the next is recurring decimal fraction. So the first one was terminating decimal fraction. So it is in the fraction form. So we will come to know it is rational. It is terminating decimal fraction is a rational number. It is rational. Okay. How we came to know that it is a rational number? By bringing it in a fraction form or knowing the finite number of digits. So next is recurring decimal fraction. Recurring means repeating. Okay, the non-terminating decimal in which some digits are repeated again and again and same order and decimal parts is called recurring decimal fraction. Here it is saying that non-terminating decimal means those decimal which don't have any ending, those decimal numbers which don't have any ending, in which some digits are repeated again and again, in which some digits are repeated again and again in same order and decimal parts is called recurring decimal fraction. Such is 0.3333 or it is continued. It is non-terminating decimal, so but it is repeated again and again in same order. So they are denoted as 0.3 bar. Why this bar is put here? Because to represent the repeating numbers, repeating numbers, same order of repeating numbers. See these are same number 0.33 and repeating. Okay, the next is 0.1666, 0.16 bar. It is 7 over 12 is equal to 0.16 0.583333 and continued. Okay, 0.583 bar. The other one is likewise 0.457457457. So it is a repeating number, non-terminating decimal repeating number. Okay, so that is why it is called recurring decimal fraction, because they are in same order and repeating again and again. So we have put bar here because they are repeating number. Okay, let me solve this one to help you gain the easy concept. For example, I will put 3 outside and 1 inside. Okay, 3. So 3 is a greater value than 1, so I will put a 0 inside, extra 0. So here a point will be put. Here a point will be put. 0 point. Okay. So in the table of 3, 9 comes in 3 times. 9 comes in 3 times. Same again, 1 remains. Again 10. Again 9. So it continues again and again. 3, 3, 3. Means it is a repeating number coming, non-terminating decimal, but a repeating. The digits are repeating again and again. Another one is non-recurring decimal fraction. Non-recurring decimal fraction means here the digits are not repeating. Digits are not repeating in same order. The non-terminating decimal fraction in which the digits are not repeated in the same order and decimal parts is called non-recurring decimal. So in recurring decimal fraction, the digits were repeated again and again in same order. But here non-recurring decimal fraction, the digits are not repeated again and again in same order, but they are repeated in different order. It is called non-recurring decimal. So it will be irrational. It will be so another type of decimal fraction is non-terminating and non-recurring decimal fraction. It is also irrational. How come it is irrational? A non-terminating or non-recurring decimal is a decimal number that never ends and does not repeat any pattern. Means it does not repeat any pattern. As I told you about the irrational numbers, it does not have a pattern or does not repeat, or it does not have an ending. For example, the value of pi is 3.14159 and continued. It does not have any pattern or does not repeat any pattern.